And in the time we have left, let's talk about water molecules. So again, we have the fluids in our body are water-based, so this is why I'm spending a lot of time on water. Remember that water, within one water molecule itself, it has these polar covalent bonds leading to slightly negative charges on the oxygen and slightly positive charges on each hydrogen atom. Now, these polar covalent bonds, again, why? Because these electrons, oxygen likes to hold on to electrons a little more than the hydrogen does. So with these electrons spending more time here, oxygen is a little negative, thus making hydrogen a little positive or each hydrogen a little positive. And again, refreshing, that hydrogen bonding is referring to this partial negative and partial positive charges being attracted to each other. In the case of water, it's due to the hydrogen being slightly positive, being attracted to other water molecules or other molecules that are slightly negative. So why does this matter? Well, your cells are about 70% water, and the human body, depending on your age, your sex, or also your height and weight and body composition, is about half to a little over half water. But the thing is that chemicals also need to be transported throughout your body, and water is a great way of doing that. So water is the main carrier of chemicals in your body. So the thing is that now you have to talk about these two terms. And these two terms are very easy to get mixed up. So when you have a solvent, that refers to some sort of chemical or substance that you use to dissolve other chemicals. So a solvent is the thing doing the dissolving. And for PHYL 141 and 142, I mean, there might be, if you're talking about the chemical sense, if you're like Chem 161, 162, when they're not necessarily talking about cells and the body, they might have other solvents. But for this class, water is pretty much the primary solvent you're going to be talking about. So when I talk about solvent, I'm pretty much almost always talking about water. We're not talking about or maybe if you go into pharmacology, you may talk about like solvents being lipid-based, but for this class, water is usually what we're referring to. So solute is what's being dissolved. So the solvent is the thing doing the dissolving, and the solute is what's being dissolved in the original solvent. So again, remember in this class for this year, water is the primary solvent. So the solutes in your body, these are what are being dissolved in water. So when you dissolve a solute into a solvent, you have a solution. So here we have a salt crystal. Remember, with all those ionic bonds, you have sodium and chloride forming all these ionic bonds just due to their positive and negative charges being attracted to each other. Well, what also has positive and negative charges, or partial positive and negative charges? Water molecules also have partial positive and negative charges. So remember, those polar covalent bonds in water make the oxygen atom in each water molecule slightly negative. So if you throw sodium chloride into water, what happens? Well, this, again, slightly negative charge is going to is going to help to break apart these ion bonds between sodium and chloride. And these negative charges around on the oxygen atom of water, they're actually going to surround these sodium ions. So yeah, it's going to form something we call hydration spheres. But my main point here is that notice that these water molecules, due to their partial negative charge, they're actually able to interact with other charged particles as well. So this is why salt dissolves in water, because these charges are being attracted to the partial positive and negative charges of water. That helps to break them apart and surround them and prevent them from forming these ionic bonds again. So again, these are called hydration spheres, and is this really important? Well, maybe you're looking at the molecular and if you're going to molecular sciences, but this is just FYI. So then we have to talk about concepts called hydrophilic and hydrophobic. So when you have something like, when you say someone's a bibliophile, they like to read stuff, right? Or if they're a biophile, they like life, they like nature. So hydrophilic means some sort of, when we're talking about hydrophile, now this is where it gets a little confusing, because in this case, it's not necessarily talking about hydrogen, but we're talking about the root word hydro, which refers to water. So when you have a molecule that's hydrophilic, that means it likes associating with water. So things like those sodium and chloride ions, they're hydrophilic. They like dissociating and associating with those water molecules. And hydrophobic, so this is the opposite. So that means that they don't like associating with water. So hydrophilic, it means refers to when we're talking about compounds and molecules in the human body. That means these are molecules and chemicals that are able to dissolve in water. So in other words, they're solutes that can dissolve in water. And hydrophobic, so these are the chemicals that are, at least in the context of your body, they don't quite easily dissolve in water. So it's hard for them to mix in evenly with the water and fluids in your body. So this is what we call hydrophilicity and hydrophobicity, whether something can dissolve in water or whether it has a hard time dissolving in water. And so let's see, we already talked about polarity. So again, referring to that, and polarity is caused by that polar covalent bonds. So this is referring to those partial electric charges. So chemicals that tend to have ionic charges or polar charges, they tend to be hydrophilic because why? Well, if they have partial or full negative and positive charges, then they're going to be attracted to the full positive and negative, or not full, the partial positive and negative charges on water. Whereas chemicals that barely have any electric charge, well, they tend to be hydrophobic. And why is that? Well, if they're neutral, then you don't have the positive negative attraction. A positive plus a neutral charge, there's no real attraction. If you have a negative charge and a neutral charge, there's no real attraction there either. So basically, you need some sort of positive negative interaction for two molecules to be attracted to each other in hydrophilicity, or when something dissolves in water. So you need some sort of charge, something for water to grab onto.